Hi, Science 7. Today, our topic 5 on earthquakes. And I think there's more earthquakes going on in Canada than we might realize. So here's a map of Canadian earthquakes that have ever happened. And you kind of definitely see a trend over in this section. So then we flip to where the plates are, remembering this from a previous topic. And when you look at the location of the plates, there is a theory that those the plates, as you see here, that are connecting with each other could be the reason for the earthquakes. So let's take a look at all of the information we know on earthquakes. They are vibrations caused by some energy release in the Earth's crust. When those plates connect and hit against each other, the energy will cause those rocks to break, causing an earthquake, which can sometimes cause, if it's under the ocean, can cause a tsunami, where if it is where there's snow and ice, it can cause an avalanche, and it can cause a rock slide. So bedrock, the solid rock under the earth, is one of the definitions that you need to know, and it's the solid area under there, and the point another definition, a point where the earthquake begins is called the focus or hypocenter. So that's the same thing. Get about there. And that's where those rock plates break. Now, this release of energy will cause seismic waves that will go in all directions, and what you feel when there's an earthquake is caused by those seismic waves that are going through the soil. After the earthquake, there's an aftershock that is caused by those seismic waves that are still moving. And all the waves that are caused by an earthquake can be measured on a seismograph that's attached to the ground, and it can check out the intensity of that earthquake. It's got this hanging pen, the drum that goes around, and a recording paper, and the earthquake, of course, it's shaking the earth, and so that pen will shake and give us that that recording that looks like this. The Richter scale, we must know about that. You've probably heard earthquakes being measured on the Richter scale before. Whenever a news of an earthquake comes, they tell what the reading is on the Richter scale. But the Richter scale does start at 0, and there is no limit to the Richter scale, but every level going up is much larger, 10 times bigger than the previous levels. So if there's major damage and deaths, we're looking at a Richter scale of 6, 7, or 8. And you can see here that there's a lot that are generally not even felt, like 600,000 a year in Earth. And you might feel them when they're around 2 or 3, and they'll start causing damage at 5. It's a major earthquake if it is in the 6, 7, 8 range. You can watch the Bill Nye Richter scale video off our PowerPoint on topic 5. So 3 kinds of waves that earthquakes cause. The primary or P waves are the fast-moving ones that can travel through solids, liquids, or gases, and the primary ones are actually small. They are warning waves that warn people that an earthquake is coming. The second one is named secondary waves, and so it's for short S wave, travels slower, and can only go through solids. You can see the S wave reading there. And The third one would be the surface wave that is the absolute slowest. It comes from the epicenter, the location on top of the earth where the earthquake started. And these surface waves, although they're slow, they will cause these oscillations that will break roads and buildings because they are intense and they will cause the most damage. I think that because of looking at what the waves travel through is how they came up with the hypothesis that the Earth's center is liquid. The scientists will use a seismograph to figure out where the focus of that earthquake is, and the focus is the spot where it starts, and the P and S waves will go from there to all directions out from the focus. The epicenter is the point on the surface where is just above the focus. So focus is where it starts underneath, and the epicenter is on the surface. And S waves and P waves, when they get to that epicenter, they will start causing those waves, surface waves. Usually we will need 3 seismographs to accurately tell where the focus and epicenter are. And so if we go to, this is kind of the way that GPS works, is we need data from 3 spots. So I just circled it down here. When you have 3 seismograph pieces of information, they will be able to intersect, and then you can tell where the earthquake focus was. They can tell the location once you have information from 3 locations, 3 seismographs. So 3 stations of information. Wherever they are in the world, once they have 3 stations information, they can pinpoint it. Now, faults are spots where very large pieces of rock hit each other. So we've got a few different kinds. Normal faults are caused by tension, and when the plates are moving away from each other, get a different color here. This plate's moving up, this plate's moving down. That would be a normal fault. That could be a cause of an earthquake. Reverse fault is when there's a one that slides up, and this one is caused by compression at a subduction zone, and it's usually when these faults are, the plates are moving towards each other, as you see here, whereas the normal faults, the plates are moving away from each other. The strike slip or transforms faults are sliding, so that's a shearing motion, and these can also cause earthquakes when those plates slide past each other. And we have a video here that you can check out about earthquakes. Last couple slides here. When people live in an earthquake zone, they know that they need to secure things in their homes. Houses and roads are built with appropriate construction and for the earthquake, to minimize the damage due to earthquakes. And the last slide we have here is about earthquakes that happen under the sea and will cause these huge waves called tsunamis that can cause a lot of damage when they hit the shore. In the mountains, earthquakes can cause avalanches or rock slides. And in some soils, the solid soil can actually turn into some form of a liquid-like substance, kind of like quicksand, because of an earthquake. So that's kind of a cool fact. Alrighty, thanks for tuning in to our earthquake lesson, and we'll catch you